Okay, we're still on chapter 37 in your Radiography in the Digital Age books, but we're switching gears to take a look at digital acquisition systems now. It's a much shorter section with a lot of terminology that you'll need to know, so let's dive in. When we say digital acquisition system, what do we mean? Well, digital is referring to the image format, and acquisition, to acquire something, we're talking about the creation and display of the radiographic image. And the system we're talking about includes the detector. We won't get into this too deeply as a lot of this will be covered in physics. Field uniformity testing just checks to see if there's any radiopaque or light artifacts on the detector. To do this, you just open your collimator and expose the detector without anything on it, and you'll see white spots if they're present. Erasure and ghosting is caused when the detector doesn't completely erase the previous image, also called image lag or memory effect. Dark noise is just unusual model or noise in the detector. Spatial resolution can be tested a couple of ways. One with a wire mesh, which kind of looks like a miniature chain link fence that goes over the detector. Or you could use a bar test pattern. You'll be looking for areas of unsharpness across the image on these. This usually indicates there's some kind of damage to the detector. We also need to be monitoring the display systems. We have QA and QC for the display monitor, which has become extremely important since the radiologists are reading from these. Because the display monitor is the weakest link, we need this system in place to maintain quality to prevent misdiagnosis of images. Because of the importance of keeping display systems functioning optimally, there have been several groups that have developed guidelines to monitor the quality of electronic images on display, including DICOM, Digital Imaging and Communication in Medicine, the AAPM, or American Association of Physics in Medicine. We follow these guidelines from this group since they perform testing on our equipment. SMPTE, the Society of Motion Picture and Television Engineers, and the ACR, American College of Radiology. One attribute we need to know about with electronic display systems is luminance. Luminance is the rate of light emitted from an LCD screen. The unit of luminous flux describes the intensity of light perceived by the eye and can be measured in a unit called lumen, which provides us with a description of power of light flow traveling through space. Much like X-rays, light travels in photons and can be measured or quantified. The term steradian is just a 3D cone of light emitted from the display screen. Again, just reviewing some terminology here. The total rate of light emitted, which helps describe the power of a light source, is measured in a unit called candela. The maximum luminance of an LCD screen is about 800 lumen, and radiologist display monitors typically emit 500 to 600 lumen. Our old light view boxes we used to hang films on, like we have in the lab at school, are about 5 times brighter. The American College of Radiology requires a minimum brightness of 250 lumen for display systems. A photometer is a device that measures light intensity. The luminance refers to the rate of light striking a surface. All types of photometers measure light flux by the amount of current generated through the photoelectric effect, which includes photoresistors, photodiodes, and old photomultiplier tubes. This refers to an older method of AEC, which is why people may call AEC a phototimer still. A phototimer would be set to terminate a radiographic exposure when the X-ray produced a designated amount of light flux. The concept that's applied to a luminance refers to the backlighting in LCD or room lighting striking the actual display. The unit of luminance is the lux. And to give you some reference points, direct sunlight produces 105 lux. A typical office setting is around 75 to 100 lux. A full moon can produce 10 lux of light, and the radiologist's reading room should be lit to about 2 to 25 lux for the best viewing conditions. Let's talk about luminance and contrast tests. These are tests performed on monitors. Luminance response is basically a contrast test of brightness levels. The other thing that's measured is the GSDF, or Grayscale Standard Display Function. Here they assign digital values of the dynamic range in line with human perception. They're only really concerned with just noticeable differences in the grayscale. Luminance ratio compares the maximum lux value, or Lmax, to the minimum lux, or Lmin. Luminance uniformity. Anytime you hear the word uniformity, think consistency. And with consistency of luminance, we're comparing brightness levels at different points across the screen or the monitor. In other words, you shouldn't have some really bright areas and others fluctuating. All you need to know are definitions here. There's a couple of ambient lighting and reflective tests you need to be familiar with as well. Diffuse reflectance refers to the ratio of brightness of ambient light in the room, which is reflected off the surface of the display monitor. In other words, it measures light coming from behind the monitor. Specular reflectance is the ratio of reflected brightness compared to the brightness of the actual light source. This is measured by light coming from behind the viewer, or the radiologist. Noise and resolution are also characteristics that can be measured on a monitor. Just note there are no guidelines for acceptable levels of noise. You just need to know that increased noise reduces the visibility of low contrast subject on the image. Both ACR and the AAPM recommend minimum resolution for electronically displayed images of at least 2.5 line pairs per millimeter, which is fairly high resolution. LCD monitors typically have consistent, uniform resolution and don't require regular testing compared to other monitor types. Dead pixel versus stuck pixel. We discussed these before, but just remember a dead pixel is not receiving a signal, which means that specific pixel is off, and it's going to appear as a white spot on the monitor. A stuck pixel just means the pixel is stuck on, or continually receiving a signal, which is the exact opposite of a dead pixel, so it appears black. Of course, if you have too many dead pixels or stuck pixels, it will negatively affect your image quality. Viewing angle is considered the biggest disadvantage of LCD monitors because it's very limited. Most expensive LCD monitors have pixel elements that are slightly angled, which allows them to be viewed from wider angles. Most LCD monitors are self-calibrating and should be checked by measuring the stabilized brightness. This requires measurement every day for the first week, then once a week for a month, and then once a month for 3 months. Luminance tests should be performed annually. Repeat analysis is the final portion of our QC and digital acquisition systems. Going back to film screen systems, we used to have to shuffle through the actual hard copy films and note the reasons for each repeat. On average, 60% of repeats were due to technical errors or processing issues. Maybe your image was too dark or too light, or there were artifacts that resulted from the chemicals during processing. Or maybe the guide shoes that carry the film through the automatic processor were slightly out of alignment and they scratched the films. A lot could go wrong with those old film screen systems. With digital radiography, only 10% of repeats are caused by technique errors. If an image is overexposed, they no longer appear too dark to visualize. Processing algorithms and automatic rescaling fix a lot. This means a majority of repeats in digital radiography are due to positioning errors by the technologist. A couple of huge disadvantages to digital imaging is that rejected images can be permanently lost, and the technologists aren't always truthful in documenting, if they document at all, the reasons why the image was repeated. These make it very difficult to perform accurate repeat analysis. There are ways we can go back and review images, but those methods may require administrator access. The important thing to remember is there is always going to be an electronic trail to follow if needed, and you should always be truthful in documenting repeats and the reasons for them. This helps you maintain accountability and provides you with information that you can further use to improve your own skills and ultimately reduce your repeat rates. But the tools are only as good as the data they receive.